Okay, so what we're going to be talking about today is kind of an extension onto what we did yesterday, except we're going to be talking in terms of arithmetic and geometric sequences. We talked a little bit about them yesterday. We found some general formulas that I told you you had to memorize. Do you remember where those were in your notes? Can you very quickly find it so that you can see where it is? We're going to be utilizing that as well, so that's going to pop up again. Okay, so we're still talking about recursion. We're also talking in terms of a common difference. What do we say common difference was? Okay, that's how we represent it, but what is it? What is common difference? What does that mean? Yeah, it's the value that's added or subtracted to get your next term, right? And that common difference, is it the same or is it different in the sequence? It stays the same, right? So we add or subtract the same value over and over again to get the next value in the sequence. Okay, so that formula, a sub n equals a sub n minus 1 plus d. That is our formula for an arithmetic sequence, recursive. Okay, notice it gives you a sub 1 as well. So we're going to use that to real quick go through these three. This should be review from yesterday. This should move very quickly. All right, so when I want to find a sub 2, again, using our formula, right? A sub 2, I'm given my formula right here, equals a sub n minus 1. What does a sub n minus 1 mean? The previous term. What's my previous term? 2 plus 6, which equals, good. All right, a sub 3. Good, 8 plus 6. We're using the previous term, right? No? Is this changing? It's not changing its place, right? All right, a sub 4. And I get? So that was quick, right? So recursion is pretty simple. You're just taking that previous term and popping it into my formula. Okay, so the next one, notice it's giving us a sub 1 and it's giving us our common difference. So you guys have to plug it into the formula and find the next three terms. So go ahead and give that a shot, please. See if you can do that on your own. Okay, how do I set up to find a sub 2? Good, 8 minus 4 equals 4. A sub 3. Good, and a sub 4. Awesome job, guys. Very nice. Okay, try C. Okay, how do I find t sub 2? Three halves plus 1/2. You're using the previous term. Previous term. Look at next term. If this is the next term, this is the term before. Yeah, current. Got it? Okay. 4 halves. Leave it that way. Don't reduce it yet. Reason being is we want to make the addition as easy as possible. T sub 3, how do I find it? Which is? Good. And T sub 4? Uh-huh. Which is? Okay. So here's 3, here's 2. 2, 5 halves, 3. What do you mean? Okay, ready? So are we getting the drift of recursion, guys? You just take the previous term and plug it in. We got it. We're good. Okay. So the next one, I'm given a sub 1 equals negative 3 plus 5i. What is that? What kind of number is that? Yes, it's in the imaginary family. What? Complex number. Good. Okay, so I have a sub 1 equals negative 3 plus 5i. A sub n, which means my current term, equals a sub n minus 1, which means my previous term, plus 6 minus I. So what's my common difference here, guys? 6 minus I, good. Which of the following is a sub 4? So go ahead and find me a sub 4, please. You should not be using your calculator to add complex numbers. You can do that on your own. Making this mistake. Guys, what does this mean? Well, let's talk about this again. What does that mean? Does it mean you're going to subtract 1 from the previous term? No. Okay? It's a variable, like a variable, and it represents the term prior. Got it? Okay, so if I want a sub 2, a sub n minus 1 means what? Which is what? And I want to add to that its common difference, which is 6 minus I. So now to add complex numbers, I just combine like terms, and I wind up with, good. How many of you got a sub 2 correct? All right, so let's look at a sub 3. What am I going to put in? Okay, and good, and I get, good, excellent. A sub 4, which I believe is what I'm looking for. What do I do? Yeah, good, excellent. Okay. All right, so let's talk about coming up with our general formula. We already talked about this yesterday. We're going to go a little bit further in depth. All right, so I have a recursive definition. I've got a sub n equals a sub n minus 1 plus 3, and a sub 1 is 5. Go ahead and find me a sub 2, a sub 3, a sub 4, and then we'll talk about b, c, and d. Okay, what'd you get for a sub 2? 8. Good, because we're adding 3 to 5. A sub 3, because we're adding 3 to 8. What did you get for a sub 4? Because we added 3 to 11. Got it? All right, so part B says, how many times is 3 added to 5 in order to produce a sub 4? Yeah, 3 times, right? I had to add 3, 5, I did 5 3 times. 5 3 times? No. I had to add 3 times to 5 to get a sub 4. Okay, so we had to add it on 3 more times. All right, so how can I use my result from part B to quickly find the value of a sub 50? How many times would I have to add 3 on? 49. If I wanted a sub 4, I had to add it on 3 times. If I want a sub 50, I'm going to have to add it on 49 times. What's repeated addition? Multiplication. So remember that formula that we determined yesterday? So what's my first term? 5. I need that, right? So I have my first term, and then I'm going to add to my first term how many 3's? 49 3's. Does that make sense? Okay. All right, so I want you to write my general formula for arithmetic sequences for part D. No, you're just writing the general formula. This is 152. Is that what you're saying? Yeah, it's 152. I know that you guys can button push. I'm not concerned about that. Okay. I want my general formula for part D. General. So using a sub n, a sub 1, d, and n. It tells you exactly what to use. Now you just have to put them in the right spot. Who's got it? D times n minus 1. Excellent. Okay, make sure you know it, guys. All right, let's move on. Okay, so example 4 says, given that a sub 1 is 6 and a sub 4 is 18, okay, we want to determine the value of a sub 2 and a sub 20. All right, so what am I lacking here? I'm lacking my common difference, right? I need my common difference in order to figure out these values, right? if I'm using this formula, I need that common difference. How can I find it? Yeah, I'm going to put in what I know and find what I don't know, right? So do I have an a sub n? What? Is that going to be my a sub n? 18, why? Where am I going to use this? An a sub 1. So I'm going to use this in a sub n. Does that make sense? Okay, so I've got 18 equals 6 plus d, that's what I'm looking for. What's n? Think about it. We used a sub 4. What's n? 4. So 4 minus 1. Okay, this is going to come up a lot. All right, find me d. I've heard 3 different answers. I'd like somebody to second the correct one, please. 4, how did you get it? Subtract 6, which gives you 12, and then divide by 3, which gives you 4. All right, now I have my common difference, right? So can I go and find a sub 2 and a sub 20 very quickly? Go ahead, do it very quickly. You have a formula, right? Use it. No, your a sub 1 is always the same thing. It's your first term. What's your first term?
Oh, 6.
Yeah. N minus 1. So here's your n, a sub 2. N is 2. That's good. So now see what you get. Okay. Okay, so a sub 2, what did you guys write? Good. Which gave you a value of 10. Excellent. We okay with that? All right, so what about a sub 20? Good, so what's the only thing that changed? Yeah, this and this, right? Everything else stayed constant. Your first term and your common difference. So what do we get? No, what'd you get? Not that. Try again. You button pressed wrong. 82. Okay. All right, so that's arithmetic. Now, here's the key. Notice this sign here? What is that? Arithmetic addition. Notice they both start with a. Okay, so you need to remember that. So now we're going to talk about geometric. Now, we're going from addition to multiplication. And we're going from common difference to common ratio. Okay, so instead of adding a common difference, we're going to be multiplying by a common ratio. Okay, so our formula, we're given our a sub 1, that's our initial term, right? A sub n equals a sub n minus 1 times r. It's the same exact thing, except instead of adding, we're multiplying. Okay, same thing. So let's talk about recursion for this real quick. This should be quick and easy, guys. We know our first term is a sub 4. How would I find my second term? Look at my formula. 4 times 2. Remember, geometric is multiplication. Okay, so this gives me 8. A sub 3. 8 times 2, which gives me, and a sub 4, which gives me, notice my common ratio does not change, just like my common difference did not change. Okay, so the only difference here is we went from addition to multiplication. Got it? Okay. Why don't you go ahead and try B, and then we will talk about the last. Scratch that. Let's go right down to exercise 6, time. We're crunched for time. I don't know how we fell behind. Okay, so consider a sub 1 is 2. A sub n equals a sub n minus 1 times 3. Okay. We can real quick get a sub 2, a sub 3, a sub 4. How do I find a sub 2? Which is a sub 3, which is, and 18 times 3 is a number, yes, 54, that number. Okay, I know I'm going quick, but you guys are good with recursion, right? So how many times do we need to multiply 2 by 3 in order to get a sub 4? 3 times. So just like before, right? What's repeated multiplication? Repeated addition is multiplication. Repeated multiplication is exponents. Okay? So if I want to determine the value of a sub 10, I know that my first term isn't going to change. And I know my common ratio isn't going to change. But the number of times I multiply my common ratio is going to change based on what term I want. So how many times would I have to multiply by 3 to get my 10th term? 9 times. Does that make sense? Okay, so how would I write my general equation? R, and R stands for common ratio, right? N minus 1. So there's your formula, your general formula for geometric sequences. Okay? All right, so your homework is pages 4 and 5. Make sure that it gets done. You have a few minutes to get it started. Get it started, okay? Nice job today, guys.